All right, let's take a look at multiplying polynomials, our first section on this. We're going to start by multiplying just with monomials, and remember monomials are single terms. And we've actually already seen this a little bit when we were looking at our exponent rules because we were multiplying terms together using the product rule. And so just looking at a quick example here, let's say that we're given 8m squared times negative 9m. Now remember for this, first of all, we have to use our product rule, which just tells us if we're multiplying two terms together with the same base, so we have an m and an m, we're going to add the exponents together because that's telling us how many of those we are multiplying. So we're going to multiply the like parts together. So 8 times negative 9 is negative 72. M squared times m to the first. Add those exponents and we get m cubed. And that's all we have to do with these. When we start multiplying polynomials in a second, it's going to be really similar. When we have more than one term, we'll be distributing. So we'll just be doing this multiplication with monomials over and over again. So we're told to multiply number 1, still looking at monomials, 2x times 3x. Multiply the like parts, so 2 times 3 is 6. X to the first times x to the first. Add the exponents and we get x squared. Hopefully not too bad, just multiplying single terms for now. Let's try negative 6x times 5x cubed. And again, if you want to pause at any point, because I'm going to be going through these a little bit faster, so I would definitely pause and try these before I actually go through and do the whole thing for you. So negative 6 times 5 is negative 30. X to the first times x cubed. 3 and 1 give us x to the fourth. All right, so these two have been nice. We've only had x's, but what if we have something, let me put this off to the right actually. What if we have something like 10x squared times negative 8xy squared? We still want to multiply the like parts. So 10 times negative 8 is negative 80. The other like parts are the x's, and then the y, there's no other y though, so we're just going to kind of tack that onto the end. X squared times x to the first. So these have their own exponents. Even though it might look like this x is being squared, it's not, because the only part of the base here is this y. If there were parentheses around the x and the y, then they would both be squared. But if you don't see an exponent, always put a 1. Okay, so x squared times x, add those together, we get x cubed. We can't multiply this y by anything because it doesn't have another y over here, but we can just bring that over because it's still part of our answer. So just multiplying the like parts. So try this one, 6mn cubed times 12mn. So multiplying the like parts, 6 times 12 is 72. M times m is m squared, and we can add the 1s in here. And then n cubed times n is n to the fourth. Adding our exponents, multiplying the like parts. Okay, so that's what we do if we're multiplying monomials by monomials. But what if we multiply monomials by polynomials? So by putting polynomials here, monomial is just a type of polynomial. So this could still imply that we're multiplying monomials by monomials, but we're going to try some where it's a little bit longer. And just like we've seen before, anytime we have a single term on the outside of a set of parentheses, we want to distribute. So let's go ahead and look at some examples. Again, we're just multiplying. Number 1, we're given 5m cubed times the quantity of 2m plus 7. So just like I said, we're going to just go ahead and distribute. I'm going to write this one out in kind of the longer format, but we'll skip this kind of in-between step in a second. So we're taking 5m cubed, and we want to multiply it by 2m, plus take 5m cubed and multiply it by 7. And then if I go ahead and actually multiply those, 5 times 2 is 10. M cubed times m is m to the 4th. Plus 5 times 7 is 35. Bring over the m cubed. So I'm going to end up skipping this middle step in the next example, but if you want to write this down every time, you totally can, or if you just want to kind of write these parts off to the side, that works too. But I'm going to go straight from here to this step. Okay, number 2. 2x to the 4th times the quantity of 3x squared plus 2x minus 5. So we want to go ahead and distribute. So we're going to take this 2x to the 4th and distribute it to each term. So now our first two terms here, 2 times 3 is 6. X to the 4th times x squared is x to the 6th. Adding those exponents. And then 2 times 2 is positive 4, so plus 4. X to the 4th times x to the 1st is x to the 5th. And 2 times negative 5 is negative 10. Bring over that x to the 4th. All right, just a couple more of these. Let's go ahead and just do one more actually. Let's do negative 2xy times 4x squared minus 3xy plus 5. This one has multiple variables, but we're still going to multiply the same. We're going to distribute. Focusing on the first term, negative 2 times 4 is negative 8. X to the 1st times x squared is x cubed. And we still have this y. The next term, negative 2 times negative 3 is positive 6. X times x is x squared. And y times y is y squared. And then finally, negative 2 times 5 is negative 10. We don't have an x and a y, so we're just going to bring over the xy from that term in the front. All right, so now let's take a look at our last type of multiplication, multiplying with multiple polynomials, or just multiplying polynomials in general. So multiplying polynomials, what we're going to do is we're going to multiply each term of the first polynomial by each term of the second polynomial. All right, let's look at just a couple of examples of this. For these examples, we're told to multiply. And again, it's implied that we're always going to simplify our answers, which we are actually going to have to do for these. So number 1 here, we're given m plus 3 times m squared minus 2m plus 1. So think of this like distributing multiple times. So we're going to distribute this m to each term in the second polynomial, and then we're going to distribute the 3 to each term in the second polynomial. And then we'll combine all of our like terms. So let's start with the m. M times m squared is m cubed. M times negative 2m, there's technically a 1 in front of this m, so 1 times negative 2 is negative 2. M times m is m squared. And then m times 1 is still just m, so plus m. And then on to the next one, we're just going to keep adding on the terms. 3 times m squared is 3m squared. 3 times negative 2m is negative 6m. And then 3 times 1 is still 3. Now, in order for this to be correct, we're halfway there. We want to combine like terms. So m cubed, there isn't another one, so we'll keep that one in the front. Negative 2m squared plus 3m squared is a positive 1m squared. M minus 6m is negative 5m. And then we still have this plus 3. And there we have it. It's just distributing multiple times, just like we did with monomials, except now we're going to be distributing however many times, depending on how many terms we have in the polynomials. Let's go ahead and try one more of these, and I want to show you guys the box method. So this is something you can always use when you're multiplying polynomials. Some people really like it, some people would prefer just to do this, so it's really up to you. So we're given 6p squared plus 2p minus 4 times 3p squared minus 5. So I think this has other names. I think some people call it the lattice box or the lattice method. I just call it the box method. And so what we're going to do is we're going to set up a box, depending on how many terms we have. We have 3 terms here, and we have 2 terms here. And so what we're going to do is we're going to set up a 3 by 2 box. Doesn't matter which side the 3 is on, which side the 2 is on. I'm going to make it horizontal, so I'll do 2 by 3, just so that I have a little bit more room. And then we're going to set up our terms on the side. So the 2 is going to go on the left, so I'll put them both here. We have a 3p squared and a negative 5, so make sure you keep the signs. Along the top, we have a 6p squared. Doesn't matter technically what order they go in. If you keep them in this order, it's going to make simplifying a little bit nicer. Positive 2p, so I'm just going to put 2p. And negative 4. And then we're going to multiply the edges together. So this top left box, we're going to multiply 6p squared times 3p squared. So that gives us 18p to the 4th. And then we can go in whatever order we want. I'll just go down. So this one down here, we're going to have 6p squared times negative 5. So negative 30p squared. In the middle, on the top, we have 2p times 3p squared, so 6p cubed. Down below that, we have negative 5 times 2p, so negative 10p. And then our last column, on the top, we have negative 4 times 3p squared, which is negative 12p squared. And right below that, we have negative 4 times negative 5, which is positive 20. So this isn't our answer. This is just kind of a method to use to multiply. We still need to write it out and then simplify. So I'm just going to list out all the terms and then combine, or you can combine in here. Actually, I'm going to go ahead and do that part, or that way of going through this. So we have, if we look at our different like terms, we don't have another 18p to the fourth, or a p to the fourth term, so I'll bring that over. And if you want, you can kind of cross them out as you go. But you don't have to do that. Just kind of depends on what you want to do, how you want to organize it. I will cross it out just so you don't use it twice. Next, we have our 6p cubed. We don't have another p cubed term, so I'll put plus 6p cubed. Again, if it's positive, it's a plus. If it's negative, it's a minus. We have a p squared, and we have another p squared. That one got erased. That was negative 30p squared on the bottom. So let's go ahead and combine those. So we have negative 12 plus negative 30 gives us negative 42. P squared. And then finally, negative 10p, we don't have another of those, so I'll bring that over. Keep using the wrong color here. So bring over this negative 10p and bring over the 20, so plus 20 because it's positive. Okay, and so we're just combining these like terms. All right, so that's the box method. You can always use that for multiplying polynomials if you'd like. You don't have to. Let's go ahead and look at the FOIL method. And this is something you've probably seen or heard of before. And this is for multiplying binomials. So this is only used for binomials because of the way that the FOIL method is set up. There's, well, we'll take a look at it in a second. So the FOIL method stands for first. The O stands for outside or outer. I usually put outside. The I stands for inside or inner. And the L stands for last. And so what this is saying, I'm not actually going to go through and do this example because we'll look at some in a second. But let's say we had x plus 3 times x plus 5. What we can do is think of it as just like distributing like we did before, how you distribute this x in, distribute the 3 in, combine all your like terms. That's one way you can still do these. This FOIL method is just kind of a way of remembering kind of what order to do things in. So first means we're multiplying our first terms of each polynomial. The O is outside, so that's the outside terms, the ones that are on the outside of each of the polynomials. So this is our outside terms. The inside terms are the ones on the inside of the two polynomials. And then the last is the last terms of each polynomial. And so let's go ahead and just look at a few examples of this. And then we'll take a look at some special products next section. And we're told to explicitly FOIL. When you're on your exams, especially on my math app, they can't see what steps you're taking. So if they're just looking for the answer, you could use the box method, do whatever you want for these ones. You don't have to FOIL. If they ask you what the first step would be if you were to FOIL, then you would have to do this. So first step is always the F, multiplying the first terms. All right, let's try number 1, 2p minus 5 times 3p plus 7. So we're going to multiply our first terms. So 2p times 3p is 6p squared. The outside terms, 2p times 7 is positive 14p. Negative 5 times 3p is negative 15p. And then our last terms, negative 5 times 7 is negative 35. And we still have to combine like terms. So let's go ahead and most of the times when you do this, you're going to be able to combine the two inside terms here. Not 100% of the time, just because based on what you were given over here, but most of the times it's going to be like this. So I'll leave that 6p squared in the front. 14 minus 15 is negative 1p, and then minus 35. All right, let's try a couple more of these. Let's go ahead and do, let's do r minus 8 times r minus 5. So again, I would pause, try this one first, and then double check your work with mine. But if we're gonna FOIL this, we'd multiply our first terms. So r times r is r squared. Outside, r times negative 5 is negative 5r. Be careful with the signs. Inside terms, negative 8 times r, negative 8r. And our last terms, negative 8 times negative 5 is a positive 40. Be really careful with those negatives. Don't forget that that's still the sign of that number. Okay, and now let's combine like terms. So we have an r squared in the front. Negative 5, negative 8 is negative 13r plus 40. All right, let's go ahead and try two more. So these ones have both been pretty nice. This next one, we're given y squared times 8y plus 3 times 2y plus 1. So this is when you have to be kind of careful with. We have this y squared in front, so we can do one of two things. Let's say we had 2 times 3 times 5. So if we remember, multiplication can be done in any order. So if we wanted to multiply 3 times 5 and then multiply it by 2, we could. Same thing here. So if you wanted to FOIL these guys first and then focus on the y squared after, you can. I'm just going to work my way from left to right. So one thing you want to be careful with here, when you're distributing the y squared, remember that when you distribute, it only goes to the set of parentheses directly next to it. You don't want to multiply it over in this one too, because if you think about something with just regular numbers, we're not going to multiply 2 times 3 and then do 2 times 5. Then we would have 6 times 10, which would be 60, and we don't want 60 for this one. This one should just be 30. So just be careful, make sure you're only distributing to the set of parentheses directly next to that term. So let's go ahead and distribute that. So y squared times 8y is 8y cubed. Y squared times 3 is positive 3y squared. We want to take this and multiply it by this polynomial here. Make sure it stays in parentheses, and then we're going to multiply it by 2y plus 1. Now we can go ahead and FOIL. So we have 8y cubed times 2y, 16y to the 4th. The outside, so 8y cubed times 1, still 8y cubed. The inside, we have 3y squared times 2y is positive 6y cubed. And 3y squared times 1, for the last terms, we have just a 3y squared. And now let's go ahead and simplify. So we have 16y to the 4th plus 14y cubed plus 3y squared. All right, so our last example here is one of our special cases. So we'll see more of these types of questions next time. We'll learn a shortcut. This one we're going to go through and do kind of the long method. So we're given 3r plus 2t times 3r minus 2t. So if you notice, we have the same terms, 3r, 3r, 2t, 2t. One is a plus, one is a minus. So that is going to give us something special when we simplify at the end. So let's go ahead and try multiplying. First terms, 3r times 3r is 9r squared. The outside, 3 times negative 2 is negative 6. R times t, those are not the same variable, so we can't add the exponents. We're just going to put them next to each other, so rt. The inside terms, 2 times 3 is positive 6. And again, we have a tr or rt to keep it in alphabetical order. And then 2t times negative 2t is negative 4t squared. So now, if we go ahead and look at our like terms here, we have an RT and an RT. Even if we'd written TR, those are still like terms. Negative 6 plus 6 is 0. So these actually cancel out, which is what's going to happen when you have what we call a conjugate pair. Same terms with the opposite sign in the middle. And it's going to make multiplying them really fast. We're going to see in the next section that we're just going to have to multiply our first terms and our last terms, and you can kind of ignore those outside and inside. So we have 9r squared minus 4t squared. All right, so we'll look at a few more of those next section, and then we'll take a look at division in our last 2 sections of chapter 5. Those are where it starts to get a little tough. If you feel a little rusty on long division with just numbers, I would try to review it before 5.8, just because we're going to be doing long division with polynomials, and it's going to be a little tougher. But if you can do it with numbers, it's going to be a lot easier.